Fine. So now what we are going to do, we are going to take this data set, years of experience and salary. And what is our motto is using the concept of linear regression, we need to find out for 3.5 years of experience person, how much salary he should get. That is what we are going to see now. So for that, first what I'm doing is let me open my spider. So what we are going till now we had worked with Jupyter notebook. So now we are going to work with spider. So I am opening spider. Please install spider if you have not installed spider. So from here onwards we will work with spider. Spider is fine. So this is spider. If you see here, this is look and feel of the spider. See, by default, when you install Spider, you will get a different thing, guys. Okay, just a moment, it's got overlapped. So you have something called as view over here. First, let me tell you, this is not the default look of Spider. I have changed this one. You go to view, you have something called as Windows layout. So you can use Spider default layout. It will be a different way. I'm using R Studio layout. Okay, so what the layout you are seeing right now is a R Studio layout because we are already familiar with R Studio layout. That is the reason. And generally, I am habitual to it R Studio layout. That is the reason I use this R Studio layout. And up to you, you can use any type of layout you like. You can use Spider default layout. Okay, or else we can use R Studio layout or anything you like. Fine, that is the thing. So here we have four windows. So for example, if you see here, so here is the part where we do code. Here is the console where you will get the output. So here we have different variables. You have different plots over here. Okay, and you can see different history and other things over here. Okay, so these are the different four parts. So once you start doing or working with Spider, you will get familiar. So I recommend you to do more R&D on this IDE of Spider. Okay, now let me go to a file. Let me take a new file. Okay, so new file. So come here. So now let me tell you the few different steps what to do. Fine. So first step, when you are starting working, step one, you have to import libraries. Okay. Step two, you have to load the data set. Import the libraries and then you have to load the data set. I will tell you step three after. So let us do step one and step three. Okay. So come here. Step one. Import the libraries. Let me open the application. So fine, come here. Import. So what are the libraries we are importing? So we do the same step again and again. Let me explain you about this library. So what we are doing, import OS, import pandas as PD, because if you see here, this is the data set which we are going to work. So in order to work with this data set, what I'm doing, I am importing this OS. Next, import matplotlib, okay, as pyplot. Fine. So why we are using this pyplot is we do certain visualization as well as that is the reason we are using this matplotlib library. Okay, and oh, see if there is two beds. So now I guess it is a little bit visual for you. Fine. Next, from sklearn.linear model. So what is this sklearn.linear model? So sklearn is scikit-learn, guys. So it is the package. Okay. So where we have different machine learning models. Fine. So from this sklearn, what we are doing, we are importing linear regression because we are working with linear regression. That is the reason we are importing this linear regression. Okay. And next from sklearn dot model underscore selection import train underscore test underscore split. So what is this train underscore test underscore split? I will tell you in a couple of minutes. First, let run this libraries. Read the text, run that one. So we had run that one. Okay, so we have something called as F9. Okay, you can uh, type with F9, highlight the text and run that using F9. So you have seen we had run that. Now, next step, what we have to do, we have to load the data set. Okay, so what I'm doing, I'm loading the data set. So you are familiar with this print os.getCWD, that is get current working directory. So this is my current working directory, users admin. So what I'm doing, I'm changing the directory where my data set is located. My data set is located in D drive datasets folder. Here. So I'm changing that one. So now I changed that one. Now if you see print os.get DWD again. So run that one. See, it is to datasets folder. So previously it is users admin. Now I have changed it to dataset folder. So after doing that one, what I'm doing, dataset equal to pd dot read underscore csv salary data dot csv because we are working with the salary data. So this is dataset, right? So we got the dataset over here. So if you see here in the variable window, you can find out this dataset. Okay. Now what I'm doing, I'm clicking on the dataset. On this dataset. So we have loaded this one. What is that? Year of experience and then we had salary. So year of experience and then salary we have. Okay. Okay. Now after loading the data set. So what we have done step one, that is importing libraries. Step two, loading the data set. Now step three, what I'm doing is I am separating X and Y. Okay. So now come here. So this is the data set. Okay. So this data set, what you could see, this data set, It has. So what is X here? X is year of experience. That is independent variable. What is Y? Y is salary. That is dependent variable. So what I'm doing, step one, importing libraries. Step two, what we have to do, load the data set. Now step three, what we have to do, separate X and Y. So now what we have to do, we have to separate X and Y. We have to split X and Y. So what is X? Year of experience. What is Y? Salary. So next step, what we are going to do, we are going to separate X and Y from the data set. Okay, so that is what we are going to do in this step. Okay, so X, Y. So X equal to dataset dot ilog colon comma minus one dot value. So what is this colon comma colon minus one dot values will do? So first of all, what is this colon comma colon minus one? So if you see here, we are taking this complete year of experience. We are taking this complete year of experience. So colon, if you observe here, colon comma colon minus one. So if you see here, what is this column? What is this one? This side deals with rows. This side deals with columns. Okay. So rows, column, nothing is there both the sides. That means give me all the rows. Columns, column comma minus one. So left hand side you have to do a minus one. So minus one is minus two. If you see here, minus one, you have like this case. You have like this column, comma, column, minus. So what is this? This deals with rows. This deals with columns. So column, nothing over here. That means all rows, column minus one. So this deals with columns. So column, that means give me from starting index. That is 0, column minus 1. For minus 1, what we have to do? Left hand side minus 1, that is minus 2. So if you go for negative indexing, so it is like this. So here, year of experience, here salary. So this is minus 1 index and this is minus 2 index. That means we will get all values of minus 2 index, that is index column, that is year of experience we are going to get. Okay, so we are going to get year of experience. And if you see here, data set dialog column, comma, 1. So that means all rows, and we are going to get this index, 0 index, this is 1 index, so 1 index is salary, so we are going to get salary. So this will get year of experience, this is will get salary. Okay, so it is not like only this methodology, guys. You can use other methodology also to get like whatever you are familiar with, whatever you practiced, you can do that one. That is the reason when I explained you the concept of pandas, data frames, I told you this uh, getting splitting the columns is very important because we do a lot of times in machine learning. So be familiar with this type of splitting work. Okay, so now what I'm doing, I'm splitting X and Y. So come here, let us split X and Y. Run that one. So we had split X and Y. So now someone tell me what this dot values will do. We had discussed also what this dot values will do.
Convert data into array, sir.
What it will do?
Convert the data into array, sir.
Yes, if you observe here, up till here it is a data frame. Up till here it is a data frame. While practicing, you can check. When you say dot values, what it is doing, it is making this X into an array. It is making X into an array. So now if you see this X, so what it is saying? X. So see on the top, it is saying it is numpy object array. See the experience what we have done, we had converted everything into an array. Okay, now you take Y. So Y everything also we had converted into array. Now what is the need of converting into an array? Why can't we keep it as a data frame? The thing is we are going to do the mathematical calculations. So for doing mathematical calculations, the machine learning models will not understand the data frames. It can only understand these arrays. That is the reason we have converted them into a numpy. So now we have done step 3, separating independent variable and dependent variable. So what is X? X is independent variables. That is year of experience. What is Y? It is dependent variable. That is salary. So we had separated X and we had separated Y. Now come to the next step. After separating X and Y, so what we are doing, we are splitting the data into training and testing. So come to this point. We are splitting the data into training and testing. So what is this training and testing? Why we need to split the data into training and testing? Fine. So for that, this is the data set. Okay. So what we will do, guys, this is complete thing that this is complete data set. What we are doing is this complete data set. First, what we will do, we will separate into first what we will do is we will separate this into four different parts, guys. Into four different parts. So if you see here, this is X, year of experience. This is Y, salary. So first thing what we will do is we will separate this thing into four parts. First, X train, X test, Y train, Y test. Okay, X train, X test, Y train, Y test. So what is this X train and Y train? So what is X? This is X. What is Y? This is Y. Do remember always dependent variable we will have in a different color and independent variable we will have a different color. Generally we will take green and blue. So green means dependent variable, Y means independent variable in general. So now this is X and Y. So what we will do is we'll split the data. How we will split X train and X test. So this is X train. This is Y train. This is X test. This is Y test. Okay. So look at me carefully here. Observe carefully. Let me take a different color. Which color should I take? Okay, can you? Okay, let me take a look. Okay. So if you see here, this part, this is X-ray. This part, Y train. This part, X test. This part, Y test. Okay. So now actually, if you see this is complete data set, this complete data set, we had first split into independent variable and dependent variable. And then now we are splitting the data into four parts. That is X train, X test, Y train, Y test. So what is this X train and Y train? So if you see, this is all training data. So what is our training data is we will train the model on training data. So by splitting the data into X train, Y train, the model will get trained on the training data. And after getting trained on the training data, what it will do is it will verify with the testing data. It will verify with the testing data whether the results, whatever we achieved, is near to it or not. Okay, it will verify accordingly. Okay, it will verify accordingly and it will check whether the results, whatever we are getting, is correct or not. So if we are not getting accuracy, correct result or something like that, what we will do, we will do the fine tuning of the model. So regarding the fine tuning and other things, we shall see in the later thing. Now try to understand what is X train, X test, and let us try to understand what is Y train and what is Y test. Okay, but this point, I guess you have understand what is X train, Y train, what is X test and Y test. Okay, so complete data is split. Now you may ask, how to split this data? How to split this data? See, we can split this data X train, X test. Okay, so X train, Y train, X test, Y test into any ratio. Okay, any ratio means generally people will follow with the 70% of the data as the training data. So we train the model on 70% of the data and we will test on 30% of the data. Sometimes we may take 80% training data and 20% testing data. Sometimes we will go 60% on training data and 40% we will use as testing data. This, how to choose which one is again a challenging one. Okay, so that purely depends upon what is the volume of your data sets, how many columns are involved in your data set. So with which split, okay, either in 70 is to 30 ratio or 80 is to 20 ratio, where you are getting better accuracy and all, you will check and you will opt for that particular split. Okay, so this is how we split the data. And this is the reason why we need to split the data. X train, Y train, X test, Y test. So we take X train, Y train, and we train the model on this particular data and we cross check with X test, Y test, and we will see whether we are getting correct results or not. So how to check with X test and Y test? So we train the model with X train and Y train. Okay, and we give 4 years of experience and we see whether we are getting this 55 thousand or not, whether we are reaching this particular value or not. That's how we will check. But how we'll check, I will show you. But we will always split the data into training and testing. So this is step 4. Okay. So what is step 1? Step 1 is libraries, importing libraries. Step 2, loading the data set. Step 3, splitting X and Y. Step 4, splitting the data into X train, Y train, X test, and Y test. So these are the 4 steps. So now let me run it again. So I'm doing that one, I'm running that one. So we splitted the data. Now you can see X test. So this is our X test experience. So this is year of experience, X test we have taken. So if you want to see Y test, so this is Y test. So if you want to see X train, so this is X train. So we are training our model on this data, X train. If you want to see Y train, so this is Y train. Okay. Now, so we had split the data. So now after that, what we have to do is we have to create the model. Okay. So regressor equal to linear regression. Regressor dot fit. So now the question is, in this step, what I am doing, regressor equal to linear regression. Have you gone through the OOPS concepts?
Calling linear regression, sir.
Pardon? What I am doing in this step? None of you has gone through the OOPS concepts. What I'm doing, I am creating an object regressor to the class linear regression. This is what I'm doing. So I have a class linear regression. I'm creating an object with the name regressor and regressor dot fit x train comma y train. Okay. So I'm fitting the model. Right. Now go back. So now make a prediction on test data. So I'm doing the prediction. So y predicted and x test. So if you see y predict. So this is salary prediction. Let us see y test. Y predict, y test. Two different things are there. So what we are doing exactly and what has happened. If you see here, these are our prediction. So after training, our model is predicting and we are cross-checking with the testing data. So this is testing data. So our model, what we have built is saying, okay, so let me take X test also here. Let me take X test also. So listen to this concept carefully, everyone. Our model, what we have built, it is saying for 1.5 years of experience, he has to get a salary of 40,835. But according to the data set or according to our testing, it is 37,731. Okay. And according to our model, a 10.3 years of experience person. So whatever model we built, regression equal to linear regression. No? So it is saying that a 10.3 years of experience person should get a salary of 1,23,079. Okay, so he have to get a salary of 1,23,079. But according to our data set, he is getting a salary of 1,22,339. So this is actual value. This is our predicted value. And here also, this is predicted value. So we predicted for a 4.1 year of experience person, we predicted he has to get a salary of 65,134. But actually he is getting a salary of 57,008. So this is what Y predicted and Y test, and this is X test. So we can cross check also like this. Okay, so this is what our model predictions is, and this is our actual values based upon this experience. Right? So if you see, we are almost near. So here also we are almost near. Our prediction here also almost near. Our prediction here also almost near. Here there is a little bit variation is there. Here also little bit variation. Here, okay. So here there is a little bit variation here. Here it is just matching like that. Fine. So you can check like this. Now I am doing a visualization. If you see scatter plot, X train, Y train. So I am taking X train, Y train, color equal to red, plotting X train, regression predicted with blue color. Title is salary versus experience, taking training data set. And X label is year of experience, Y label is C is salary, and PLT dot show. Correct. Yeah. So if you come here, see. So this is the best fit line base. And on the screen, whatever you are seeing, this is the best fit line. So here what we are plotting year of experience and salary. Okay. So this is the line which is going, touching all the points. Okay. Now what is this? This is on training data set. Okay. So just for you to see the visualization, I have done that one. Now you can see the results also. See, these are the results. So our best fit line is passing through the test set. So this is the test data, whatever we had seen. See, almost we are near to many values. So only difference is just now I had opened and show you, right? So there is one difference between 63,057. That is the difference, and almost everything are same. So here there are two differences, and here there is one difference. So if you see, let me open that one. Go to Y predict, Y test. Okay, next. See, this is 40,835. This is 33,731. So see this one. So that is the difference of that is line saying actually this is the actual value. Okay. And next 1,23,000, 1,22,000. So where is 1 lakh? So this is here. So almost a little bit is missing for 10 years of experience. Okay. So that is the visualizations, and that is the best fit line. So who has taken of this best fit line? The model is doing. You are not drawing. So after the model, after drawing hundreds of lines like this and finding the line with highest R square, so this is the line with highest R square. Do remember. Okay. Now, so now what I'm doing, I am creating a user input for entering the experience. So on that one. So here what we have to do. So if you see here, enter the year of experience. So what is our target? Our target is for 3.5 years of experience person, what should be the salary? That is what we need to find. So what I am doing, I am entering 3.5 years. Enter. So what the model is saying, what the model, according to our model, what we build, it is saying that a person with 3.5 years of experience, his salary should be 59,526. Okay. So likewise, you can predict for anything. For example, run again. So enter the year of experience. This time, I am entering some 2.7 years of experience. Okay. Sorry, 2.7. Let me write it again. 2.7 years of experience. See, a 2.7 years of experience person should get a salary of 52,050. Okay. So now let us run it again. Now we enter year of experience. I'm entering as 11 years. For 11 years, how much should be the salary? Let us check. See, for 11 years, the salary should be 1,29,620. Okay. So likewise, you can do the prediction. And who will take care of these predictions? The predictions are based upon the best fit line. So this is the best fit line. So 11 years of experience. How much salary you have to get? 1,29,000, something like that. So it will come around here like. So this is the line with highest to R square. Based upon this line, we do the predictions. Okay. That's how the linear regression works. Fine. So we stop recording. Okay. So this is about linear regression. And in the next session, next video, we are going to see about multiple linear regression. So just now we had completed simple linear regression and we shall go with multiple linear regression.